In this next inquiry question, what we look at is how science and how science data can be interpreted. And this is a really important thing because often scientific information, scientific data, scientific investigations involve very complex variables. And so it's really important that people doing these scientific investigations do it in a way that can easily explain what they're doing. And it's also important that this means that people don't misinterpret this or use it for nefarious means. So a few things to get us started is that in a lot of scientific investigations, particularly in medical investigations, there's a concept of a placebo. And so often there's hundreds, thousands, tens of thousands of drugs created constantly. And these have to go through a process of testing. And one of the main ones, after it's gone through cell tissue tests, it's gone through things like mice tests, and that they go to human testing. And one of the first levels of human testing is actually giving someone the drug. Now, of course, often there is a idea that if someone takes a drug and they believe it's going to work, they're going to feel like it works. And so in this case here, when drugs are first tested, they're done in a certain way where the placebos are used. And the placebo simply is something, it looks like the actual drug, but it doesn't have any of the active ingredient. And so the person taking it, as far as they're concerned, they're taking the drug. And so at the end of the study, they can see whether there was an effect. So did the people taking the drug have better health outcomes than those not taking the drug? And this means that it makes it easier for the investigators and for the scientists to determine that something actually works. Now, this is done through a process called double-blind trials. And in this case here, as I mentioned before with the placebo, the group receiving the placebo, they just think they're getting the drug. In a double-blind trial, the person supervising the trial also doesn't have any idea what the person is getting. And this is a really important thing to make sure that there's no unconscious bias. There's no, if the scientist or the investigator thought they were giving the proper drug to someone, they might be positive. But if they gave what they thought to be the placebo to another group, they might be a little bit negative. And so it's taking out that unconscious bias there. And it means that once the data is all collected, then this anonymity is stripped away and the data can easily be compared with each other. And of course, this is also this idea as well, that if you get the placebo group has similar outcomes, that must mean that the drug actually isn't working as well, or it's not as effective as people first thought. And of course, that idea of the placebo being a control group is a really important concept, just so it's really clear the efficacy of the treatment. Now, when it comes down to a lot of these things here, they break down to two ideas: the impact on society and the impact of economics. And both of these things, while they can be separated, are intrinsically linked to each other. In particularly the Western, or you could argue a good portion of the world is a free market, capitalist economic system. And it's framed around this idea of selling things and being productive and getting that there. And these two things as well, society for the most part, people want to be happy, want to live reasonable lives. These two things have to live in balance with each other. And of course, one of the really big ideas in the last couple of decades is this idea of climate change. Now, climate change, probably came to public attention mainly in the 1980s, maybe even the 1970s, where scientists were predicting this thing called global warming. Now, of course, what has happened is that it's changed. The focus has changed a little bit over the years, and so it's not just global warming, There's things like massive storm events, and it's just that there is a change in the climate. And of course, in terms of society, most people get their views, get their ideas from the media. And the media, even though at the heart of all media organisations it is supposed to be about reporting news and that there, you do get biases. The most obvious one is particularly in the United States with Fox News, which is openly a right wing or a conservative news broadcaster that supports Donald Trump or used to support Donald Trump. It's gone a bit off on that in the last amount of time, but they have a lot of money invested in their news organisation, so they need to get people coming on board. You also have a lot of people get their information and news now from social media. And social media, again, use algorithms, and the more you look at something, the more it's going to give you that there as well. So there's this feedback loop for people in social media. Particularly Facebook is probably the most nefarious of this. If you search for something, a second later, you'll get ads for that thing. If you search for a news story, they will start giving you more news story there. So if you're someone, and it's probably more in the United States, that there's a very definitive partisanship in terms of being a Democrat and a Republican. And so if you're searching for news on Donald Trump, you're probably going to get more positive Donald Trump stories. Or if you did searches for Trump idiot, you're probably going to get more left-leaning things there. And so often what happens there is that people's own biases are compounded. And so they don't get the other side, they just get the one side all the time. Now, of course, one of the problems of climate change is that there's a lot of money invested in a lot of different companies. And so the largest polluters are things like the oil companies, electricity generation and things like that. They make billions upon billions of dollars every year. And so they also are able to influence things. In the US and in Australia and probably in a lot of Western countries as well, they can pay money or they can donate things to particular organisations. And those organisations, and particularly in a political sense, will then make decisions that benefited those people. So essentially what happens there, particularly those large petroleum producers there, they produce fuel. We burn coal for most of the fuel of most of the electricity on the planet, and that produces greenhouse gases, particularly carbon dioxide and carbon monoxide. And of course, the way that operates is that we do get energy down from the sun, it hits the earth during the day, and then at night it radiates back out. What happens when you've got an excess of carbon dioxide is that not as much radiates out. And it is a subtle issue as well, because the planet does need some greenhouse effect. If we didn't have the greenhouse effect, then the temperature at night would drop below zero. We need a little bit to moderate that temperature. And that's why planets, as far as we know, Earth is the only planet in the solar system we know that there's life on. And that's because we have a thick atmosphere that holds in some of the energy. If you go to a planet like Mars, the atmosphere is a lot thinner, and so the temperature differential between hot and cold is a lot bigger. Our main problem, though, is that we as a society for several hundred years have been throwing a whole heap of extra carbon dioxide into the air. So since the Industrial Revolution started, and particularly in the majority of the world after World War II, huge amount of industrialization across the world. And as this graph shows, from about the mid 50s, 1950s, sort of after the Second World War, the amount of, or the temperature, average temperature per year is increasing. And it's every year is slightly warmer than the last. And there is a lot of debate, and the debate comes about because of the fact that to move from a carbon fossil fuel economy to a non-carbon fossil fuel economy is going to be expensive. And there is a debate about that, and the idea is, well, it might be expensive now, but it's probably going to be more expensive in the future. And of course, when people say, oh, we're only talking about this now, this idea does go back a long time. You've got some well-known Fourier wrote a paper in the 1820s on this. There were scientists in the mid-1800s discussing climate change and the effect that carbon dioxide was having there. And so, it's been well known for a while. You also have, as well, in the mid-1850s, where there was a lot of recording of temperature. And it's even when you look at that there from a distance, it is increasing. There is a definitive change from where we are and where we were. And it was in the 1960s where, direct measurements of the atmospheric carbon dioxide as well. And there is a distinct correlation. As the amount of carbon dioxide in the atmosphere goes up, the average temperature is going up. And as we also got there as well, it has come to a bigger debate, particularly in the last 30, 40 years, satellite observations. Most countries have meteorological bureaus who look at this data, and the amount of data is quite overwhelming. And there has been, the amount of data against climate change is really infinitesimal. Another big area is remedies for health conditions. And in this post-COVID world, this is a really important thing as well, because we've had a whole heap of stuff since the beginning of 2020 about people trying to sell cures, trying to sell treatments. And then you have a whole range of different things as well, particularly because some countries, particularly in the Asian areas of the world and in a lot of African places as well, they've got traditional treatments. In Australia, there is a whole range of traditional medicines, some which are very effective, some are less so. And so some people may actually reject modern medicine. There's also been issues as well with the things that we'll talk about in a second. And of course, economics is an important part of this as well. The amount of money required to bring a drug to market is in the billions. And so large multinational biotech companies invest a lot of money into developing drugs. And a good portion of those drugs will never come to market because they look as though they may work, but in the end, they don't necessarily work the way that occurs. And so in some cases there, drugs when they first come onto the market are very expensive. And that's how these giant companies are able to recoup some of the money. Eventually, after a period of time, those drugs will become cheaper as the company's recouped all its costs. And eventually, it may actually become sort of a publicly well-known thing there. So, some of your common painkillers are just generics. You also have things there. During the early stages of the COVID epidemic, you had people like Donald Trump promoting hydroxychloroquine. You have people later in the thing talking about ivectomycin, drugs, one that's used for malaria, one that it gets rid of parasites out of cattle and livestock. And so people do this because, one, they're trying to spread misinformation, but they're also trying to make some money off that. One of the well-known ones in Australia is Pete Evans. Used to be known as a celebrity chef, but he's no longer doing that. He got fired from his job as a celebrity chef, and he sort of promotes a lot of wellness stuff. So in the early days of the COVID pandemic, he was actually promoting this little device he called a biocharger. And the claim was that this little thing that glows and gives off specific radiation would be able to cure COVID, There was, oh, you put this setting on there, it'll get rid of COVID. Essentially what it is a pretty light. But his company, his online website, was selling this thing for $15,000. And, he was originally fined $25,000. I think there was a lot more legal action afterwards as well. There's no medical proof for this. I think part of this came about, they were sort of saying this is like a way of making aura cleansing and things like that. And again, these sorts of claims need to be tested. When you go back and you look at the traditional medicines, a lot of those have been tested. Some have been shown to be false, some haven't. But in terms of things like biochargers, Gwyneth Paltrow, Hollywood actress, has her own website as well, which does similar things. Do these claims stack up? And I feel sorry for anyone who paid $15,000 for a pretty light. You also have as well is that there's also cases where data has been manipulated. And so you can look at the Pete Evans biocharger thing there. That's just a ridiculous claim. It's a ridiculous claim that really doesn't stand up. But what is probably of an even bigger concern is when things appear to be well done, but they're not. And so the most famous one here is probably the supposed link between the measles, mumps, and rubella vaccine and autism, which was a study done by a former United Kingdom doctor, Andrew Wakefield, who claims that the MMR vaccine was causing problems in young children that led to autism. Now, of course, that caused a stir at the time. It was published in The Lancet, one of the most esteemed medical journals. And from there, in that period of time since then, a whole range of people have stopped vaccinating children. And people claim, well, it's definitely caused it. Part of the reason was that the tests done for autism used to be done at about 18 months, which is about the same time as the MMR vaccine. And so there was a sort of a correlation. There was a correlation between the two things, but there was no causative effect. They were just two things that happened at the same time. Now, of course, the initial study, when you consider sample size, was done on 12 children. And it was later also revealed that this part of the study was actually paid by a law firm that was suing vaccine manufacturers. And so in this case here, it's really important to work out who's paying for the research. Now, of course, this isn't always just about people with nefarious means, so someone being paid by a company to promote this here as well. Even some of the big institutions, so something like the University of Sydney, which you would normally consider to be, it's an old Australian university, it's got a very good reputation, their research would be good. However, one of the problems in the modern educational landscape in Australia is that universities have to get funding from places, and particularly older universities like the University of Sydney work with a lot of public and private companies. They receive money from companies to do research. And so in 2019, they released a study saying elderberry extracts can fight symptoms of flu. And this looked like an interesting thing. It got reported in a few places. And then very quickly, the university retracted all their data because it was revealed that the study was actually paid for by a pharmaceutical company who was, funnily enough, just about to release an elderberry extract to relieve flu symptoms. And so in this case here, it's really hard to trust the research when a company who wants to sell a product has actually paid for it, because they're not going to be too happy and they're going to start cherry picking results and that as well.